Hello, everybody. We are back doing another live lesson from home. For those of you who tuned in on Tuesday, welcome back. And for those of you just joining again, we're glad that you guys are here. Obviously, we're all in a little bit different circumstances than I think we are used to, but we're trying to make the best of it. Trying to bring some lessons to you guys from home, so that you guys can learn from home, stay engaged, and really we're just trying to have some fun and make some fun in light of the situation here. So today we are actually going to be going through our STEM curriculum on shark senses. This is a presentation that is made possible by SeaWorld. They are one of our extremely important partners, especially when it comes to building these big collaborative science teams. They provide veterinarians who will be on the ship with us, and they do important work like on the ultrasound machine. Dr. Giselle Montano is doing some incredible research on shark reproduction, some of the first of its kind. She's setting a baseline for white shark reproduction health. And SeaWorld is really a very important partner in helping us do education curriculums like this and putting together some awesome science teams. Speaking of awesome people, joining me today, I have our education ambassador, Lindsay Loeffner, and our chief science advisor, Dr. Bob Huter. Lindsay has been with OSER since about 2015. She's been on right around 10 expeditions or so. Is that right, Lindsay?
That's right.
You'll see her, on the ship. She'll be doing tours all the time. But most importantly, she's really the one in charge of really putting together these really incredible STEM curriculums that are free and available for everybody online. Dr. Huter is from Mote Marine Laboratory, who's our director at the Center for Shark Research. And he really is a very important part of developing making sure that our science is exactly where it needs to be. So welcome, Bob and Lindsay. So Lindsay, do you want to tell people where exactly they can find these STEM curriculums?
Absolutely. If you go to osearch.org and under the programs tab and click on education, you can find this. We have two activities we'll be doing today. One is from our grades 6 through 8. You can click on that tab and find shark senses there, or you can go to our Mid-Atlantic STEM packet, which is connected to that expedition.
Awesome. So just so you guys know, we're going to jump into the presentation here. If you guys have questions, please leave them in the comments. I'll be moderating and kind of going through and taking notes as they come through. We'll have a question and answer session at the very end where we'll come back and do the questions. So please leave them there, and we'll get to them when we can. And with that, we will jump into our presentation on shark senses, starting with the white shark brain. Dr. Huter, do you want to kind of tell us a little bit about the white shark brain?
I was trying to turn my mic on. I'd be happy to, John. And hello, everybody out there. Hope everybody's staying safe in this very trying time and listening to the scientists and the medical professionals. That's where your best information is going to come, and how we should all be social distancing and handling this, which is what is basically a problem with Mother Nature at the moment. So let's get a little diversion away from coronavirus for the next half hour. Let's talk about shark senses. And the white shark brain is actually quite large. People think of shark brains as being kind of small, but sharks in general have very large brains for their body size. And John has put up a diagram from a chapter by Dr. Jane Gardner and a number of us other co-authors a few years ago. It's odd looking, but it's very well developed, and it's designed to receive information from all the various senses that we're going to be talking about today. On the left is the area that serves the nose and olfaction. In the middle is what we call the midbrain, and on the right is the hindbrain going out to the spinal cord. So with that, I'll turn it over to Lindsay.
All right. So in the brain, one of the senses that it is able to process is vision. So we'll start with vision, and I hope you'll follow along. If you've been following us on social media, hopefully you'll hear some of the answers to the questions we've been posting leading up to this presentation and lesson today. So shark vision, we'll start there. Sharks' eyes have similarities and differences to people's eyes. It's how they're able to see. They have different pupil shapes. They do have an iris, and they do have a pupil where they can let light into the eye. They have a retina like people do, but they also have another special feature that's part of that eye that people do not have, and that's the tapetum lucidum. I'm still learning how to pronounce these, but it helps reflect light into the eye and to be able to help sharks see. There are also rods and cones.
Lindsay?
And to go into more detail about vision, I'm going to go ahead and turn it back over to Dr. Huter.
Before we do that, Lindsay, I think people are dying to know which shape is, or Dr. Huter, you can answer.
Yeah.
If any of these is the correct shape for a white shark pupil.
Well, actually, you might be surprised to know that the answer is all of them in one way or another, actually. The round shape is what we see in some of the deep water sharks, and even the white shark has a roundish pupil. The horizontal shape in the upper right is what we see in hammerheads. The vertical slit is very common in the inshore requiem sharks like sandbar sharks and lemon sharks. And the left is a kind of a simplified version of a type of pupil in which the top flap goes over the bottom, and that's what we see in some rare sharks, and then in things like the relatives of the sharks, the skates, very common in there. So they all serve different purposes. But the cool thing is, remember, sharks are fish, and the other fishes basically don't have movable pupils. Only the sharks and some other restricted forms.
That's really cool. Dr. Huter, can sharks see in color? I've had that question coming across in our comments before too.
Well, now, Lindsay, that's a very complicated question, because we know that they can distinguish between colors in certain kinds of testing, but how do you actually get inside of a shark's head and see the world the way it sees it? We think that they don't have the kind of vivid color vision that we as humans have. But remember, our eyes are almost the best in the animal kingdom. Our eyes are really near the top, only beaten out by the eagles, the falconiform birds. But sharks do have these rods and cones. They have the capability for color vision, but we think it might be a little muted compared to the vivid color vision that we have with our eyes.
Here you can see an illustration too of a shark seeing in contrast, correct? So the tapetum lucidum, it plays a role in a shark being able to see in murky or cloudy or less than ideal visibility situations. But I believe it's also, is it not, found in nocturnal animals as well? So with that, we'll go ahead and turn it over to our activity from the grade 6 through 8 lesson plan about this piece of tissue that's in the shark's eye. So what you would need at home is either a black piece of construction paper, a piece of blue paper, or I use blue felt, and this is a piece of aluminum foil. And when you open, you will fold the paper in half so you can see the reflective surface. You won't need to see that today because we're just going to go ahead and do this. So this would be an eye that does not have that tissue in it. See how it's not really reflecting all that well? Now take a look and see how reflective that the aluminum foil is, mirroring back that light into the eye. It's pretty cool, huh? All right, so we talked about shark vision, and I can't thank you enough for sharing what you know about it. And we'll go ahead now and move along to shark hearing. Now, I don't recall ever seeing a shark that has the same structures of an outer ear that people have. But what I believe they do have is an opening behind the eye that is used for being able to hear low frequencies, I believe, and it also helps with their balance. Could you elaborate, please, Dr. Huter?
Yeah, so sharks actually do have very well developed ears, inner ears in the head. And the opening to those inner ears, you're right, Lindsay, they don't have anything like a pinna, like we have our earlobes, but they have an opening. On some of the sharks, it's actually in the top of the head on either side of the midline. And that canal that you see going up at the top of the diagram is what goes to the outside there. And sound is transmitted down through that. The ear itself is kind of similar to ours. It has these semicircular canals that are used for balance and sensing acceleration. But the actual detection of sound is actually not very well understood how it happens in sharks, but we think it happens in one of these bag-like swellings of the inner ear called the macula. And there's a thing called a macula neglecta that scientists are focusing on. So there's still a lot of mysteries about how sharks hear. We know they hear low frequencies, and that's primarily what they're listening to, but how they directionalize, how they determine the direction of a sound is still actually a subject for research.
Wow, is that really interesting? I love that there's still so much to learn about these amazing animals. Also, another sense that they have, that we also have as people, is smell. And I learned so much from Dr. Huter about their sense of smell. Because especially in white sharks, which we will focus on white sharks because OSEARCH is doing the North Atlantic White Shark Project, I learned that using their sense of smell, a white shark will start downstream from its prey and be able to pick up the sense of smell from prey downstream, which is different from other shark species. And it can also lead to them being attracted to something or be part of their behavior. So I found that really interesting. Dr. Huter, do you want to talk more about white shark sense of smell?
Sure. Now, this is really where sharks excel in the animal world, because their sense of smell is extremely sensitive to the kinds of chemicals that cue them in for various tasks, mostly for feeding. It's exaggerated sometimes. You read sometimes in popular literature that they can smell a drop of blood a mile away. That's a bit much. But other sharks that have been tested, and understand that it's hard to test a white shark under these circumstances to figure these things out, but other sharks, similar sharks that have been tested, they're sensitive to a drop of blood in about the size of an Olympic-sized swimming pool when that blood is dispersed. So they can sense down to the parts per million level. And they use this as they swim along, and they find the concentration gradients where it's getting stronger and stronger and stronger, which guides them to the source of that smell and probably to the food.
And as it's guiding them, is that part of their circling and trying to figure out where that prey is and picking up on that scent?
Yes, it is, because if you have a corridor of odor coming down from a source, as the shark swims back and forth through that corridor, it goes in and out of it, and it gets higher and higher concentrations as it gets closer. And that's what leads it to what it's looking for, which might be a dead floating whale. It might be a place where seals are hauling out on the beach and producing a lot of smell in the water. This is what sharks use to find their prey. And maybe they also use it to find a mate by detecting these other kinds of smells called pheromones.
I found that really interesting, that the pheromones could even be detected. That's absolutely amazing. Is it true it's about 14% of their processing and their brain is dedicated toward their olfactory senses? Yeah,
a large chunk of that forebrain is for the sense of smell. It used to be thought that it was all smell. Now we know that it actually serves more of an integrative function for all of the senses. But smell starts with those two big olfactory lobes that were in the front to the forebrain, and then it gets integrated with information from the visual system and the other senses that we've been talking about today.
Hey, real quick, Lindsay.
Yeah.
Will you please mute your mic when Dr. Huter is talking, and then it'll eliminate some feedback. Excellent.
Sure. All right, so we'll go ahead and move on to their sense of taste. So if we're a white shark and we start to pick up on a scent that may be indicative of prey, then we start to hone in on where that location of that prey item is. Once a white shark finds it, they're able to then explore with their mouth and investigate that source with its mouth, and we get that sense of taste. People have a sense of taste, and so do sharks, but it's different. We have a tongue in our mouths with taste buds in it, and white sharks don't, or any sharks really don't have a tongue like we think of it, but they do have a way to taste, and they have some pores or openings in their mouth and into the back of their throat, and they're able to taste that way. So that way, when their mouth goes around a potential prey item, it helps them determine whether to accept or reject that prey, hence your investigatory bite, as I understand it. Dr. Huger, would you mind elaborating and sharing what you know about their sense of taste?
Yeah, sure. If you look at that photo, I think John, this is perhaps Luna. I think it's Luna. It's either Luna or Unamaki. I'm pretty sure it's Luna from Nova Scotia. And you look inside the lower part, and you don't see she can't do that. She doesn't have a big muscular tongue that she can manipulate food and taste with. But there are taste buds all lining that lower surface of the mouth and the roof of the mouth that allow these animals to distinguish between something they really want to finish ingesting or something that they want to spit out. And sharks will reject food that doesn't meet their liking, whatever that may be.
Oh, excellent. That's fascinating. They also have a sense of distant touch, and this is also different than what we think of as touch, because we will touch things with our hands, and sharks obviously do not have that. And they don't really use their fins even for touching either. The distant touch that we're going to be talking about today comes from their lateral line. And that lateral line is able to tell pressure changes and also be able to detect movement within the water so they can sense what is around them. Would you mind sharing about how cool the lateral line is for a shark?
Yeah, this is something, a fascinating sense that's shared by most of the fishes. It's very well developed in the sharks. And as Lindsay said, it can detect such things as movement of water and low frequency pressure movements to tell if something's in the neighborhood. You can think of it this way in our experience. We don't have anything like this, but think of it this way. You're standing on a roadside and a big truck goes by you, and hopefully misses you, but goes by you, and the air that is pushed by that truck onto you, you feel that, and your mind says, oh, that big truck just went by, because you heard it, and all other things happen too. This is kind of the way the lateral line works. It feels the push back and forth of water that's moved by moving objects in the water, and allows the sharks to be very tuned in to everything that's happening in their immediate area. It works very close to the animal.
Oh, that's fantastic. That's really interesting. Now, other fish, I believe, too, also have a lateral line. It's not just sharks that have this lateral line, too. So you can see it there in the photo, that red line that's going down along the side of the shark. That is what we're referring to. That is the lateral line. I know, at least in the fish that we've dissected in our perch in our class, we are able to even see the difference in the structure of the scales, at least of teleos fish or bony fish, because the scales on a fish look different with where the lateral line is. It's almost like a tube, right? And that's how they're able to feel that pressure and have that sense. And last, we had a lot of people really interested in the ampullae of Lorenzini specifically, which is part of a really cool sense that people don't have anything like. It's their electroreception or electrosensory system. Could you tell us how that information is helpful to a white shark and what they use it for, please?
Real quick, Bob, I just want to let everyone know I do see your questions coming in. I'm making note of them on the side, and we will get to all of them here in just a sec. So I don't want anybody to think that we're ignoring them. So we will do a Q&A where I'll ask some of the questions that I've seen coming through. So don't think we've forgotten about you.
That's great. Obviously, in half an hour, we're giving very very superficial justice to this incredible subject of shark biology. And the most incredible sense, you're right, Lindsay, is electroreception. And this is something that's fairly unique to the shark world. Some other fishes might have it to some extent, but sharks are really well developed. And they use this sense very close to their own bodies. It doesn't work far away, but it only works within about a body length. And they can use this to detect the bioelectric fields that come off of living prey. So they can find something that's buried in the sand, for example. If it's a shark that's going for a stingray is not really, it's visually covered, but electrically, as the shark goes over, kind of like a metal detector would in the sand, it picks up that hum of that's coming off that living animal that's in the sand and be able to go after it. We think that they use this bioelectric or electrosensory sense to possibly even navigate and tell magnetic north. And a lot of that is theoretical, and some of it's been confirmed. And we think, based on the fact that we know that these animals navigate very precisely, that this is something that they're doing. But it's a complicated thing, and to prove it on a white shark is very difficult. So we use other smaller species to experiment in the lab. But it's an incredible sense. It is, like Lindsay said, nothing that we have, and it reports to the hindbrain of that white shark brain, and eventually gets integrated with other data from the visual system, the sense of smell, and so on.
And that's something that I found interesting too, as I've learned about shark senses from you and our scientists, is that there really isn't a hierarchy of their senses, of how and when they use them, right? It's about bringing all of those pieces of information together, and is what makes them so successful at what they do and their role in the ocean, right?
Yeah, that's true, that the brain is sort of the integrative center. But depending upon the species, sometimes they put a little bit more emphasis on one sense versus another. And the white shark is one that's more of a visual species, predator. There are other species that really rely more on smell, and others that rely more on electroreception. But they all use all of these things and integrate them within that fabulous brain.
Well, I think it's time for us to bring it all together with an activity that I've used with like kindergartners up to second grade. And it's based on an activity called the mystery box, which is lots of fun. So right now, kiddos, you can pretend that you are using your senses like a white shark, all right? And what I brought with me to show you how it all starts to come together is I have a shoebox, or I use an old lid from a shoebox that I can stick my hand into. A box, a mystery item. And then I'll have usually some sound cues to talk about that hearing, that low frequency. And so when a white shark starts to investigate a potential prey item, all these senses start to come together. So if you're a white shark and you pick up a scent, and that is something that attracts you to what you're about to investigate, you're now on the scent and you're starting to circle maybe or come upstream because you started downstream. And you might come across a vague shape like this. I made out of felt my own little mini Chewy the seal, if you will. But this is a seal shape that shows that contrast. It's just a shadow. You can see how maybe you can have some mistakes just by going by shadow. So you have one piece of the puzzle. You can see, ooh, there's a shadow and it kind of looks like a seal. You start to maybe detect the movement, and is the movement that like a seal? Maybe it is. And then you go, okay, I think it's time to investigate whether this is a seal or not. And you take your box and you see what's in here. Oh, that's fur like a seal for sure. And to check to see if you want to accept or reject that prey as a white shark, let's see what's in here. A seal. Yeah, that is definitely on the menu for a white shark. One of the research projects is studying what our sharks are eating. That's part of a nutrition study. And in Nova Scotia, it was really interesting because you guys found some pretty decisive, definitive evidence of what they're eating up there, huh?
Yeah, we did. We look when we have our big sharks up on the OSearch platform, we're able to do many different things that you can't do when the sharks are in the water. And one is to look at sharks' poop, to put it bluntly, and look at and see what's in there. And we have people that are looking at the DNA of the prey species, but sometimes right on the deck of the ship, we can see something like fur. Now, they're not eating bears and they're not eating dogs, we hope, but they are eating seals. So that fur belongs to seals that live up there in that part of the world.
So real quick, before we start wrapping things up here, Dr. Huter, one of the big things that OSearch is working on is we support 18 different studies. Are any of the studies that we are supporting directly helping us understand any of the senses that we talked about today?
As a matter of fact, John, yes, we have a project that's led by Dr. Christine Bador at Georgia Southern University, and Christine is looking across the whole suite of white shark species at the development and structure and the functioning of eyes. And she's looking at how eyes work in the shark world by habitat and by species of sharks. So yeah, we're taking photographs for her of the pupils and the eye size so that she can plug those data into her study of all these shark species.
Okay, so I'm going to quickly jump back here. We'll take a couple of the questions that you guys have answered. Here was a good one. Do sharks use our interpretation of touch when they bump into things? So do they, you can see the question, Dr. Huter. I think you're probably the best person to take this one.
Yeah, for sure. Now they don't have skin surfaces like we do. They obviously are covered with these very tough scales, almost like an armor. But in between the scales, as Lindsay said, there are these little receptors that can function in terms of touch. And yeah, they can, when they bump, they can test the sort of the flexibility of the prey, maybe some chemical aspects of it. Some of these receptors actually do respond to chemical cues, almost like a distant type of a taste that goes down the skin of the animal. And then we talked about the distant touch, the lateral line, using that to sort of gauge how big something is, tell the difference between a boat going overhead and say a seal swimming overhead. Yeah, I mean they definitely use that in integrating the data, driving their decisions how to behave.
Excellent. So here's another one. We did touch on this, but I guess, Dr. Huter, can you make it a little bit more clear for Violet? Sharks don't have a tongue. We already discussed that. So how, if they had an ice cream cone, would they be able to taste an ice cream cone?
Well, Violet, I don't know about the ice cream cone. I don't know if they really care much for an ice cream cone, but think about how your tongue works. So your tongue actually does two things. One is it's got this great sense of taste with all the taste buds on it, but it also, when you eat, it also helps to manipulate the food in your mouth as you chew up your food. Sharks don't need to do that because they pretty much bite and swallow. And so they don't need a tongue for the food part. And instead of having a muscular tongue, they have their taste buds all on the roof of the mouth and on the lower surface of the mouth. And they're getting information to their brains just like you do when you taste that ice cream cone, except in their case, they're probably tasting a seal.
Okay, so this question came in when we were talking about sharks circling and kind of starting from downstream to follow a scent. Is this an actual observation that has been made in the wild to your knowledge, Dr. Huter?
Yes, it has. There's lots of anecdotal information of white sharks finding their way to things like dead floating whales. But again, because white sharks are difficult animals, they're relatively rare and they're big to work on in sort of an experimental setting. Most of our information of this has come from other species where people have been able to see the movements of animals in response to a trail scent. And of course, one of the things that we occasionally use in our methodology is a practice called chumming. It's a common fishing method. We're just attracting sharks that are in the area, but the reason that chumming works is a shark will go across our chum line, perhaps a couple hundred yards away from the ship, and pick up on that, and then turn and start to orient and come over to where we hope to capture it. So we take advantage of that behavior in them, and they definitely can, to navigate in the wild to the source of a scent.
Okay, so we have another one here. We talked about, so humans, we have 5 senses, right? We discussed how sharks actually have that 6th sense, the electroreception, which is sort of above and beyond. This question is a little bit more general. Do all shark species have all of these senses that we just talked about?
Pretty much. Now, as we said, in some species, one sense is developed more than in others. In some species, vision is emphasized, in others, smell, in others, perhaps electroreception. So you see sort of a bigger development of some of these 6 senses depending upon the species. And some wonderful work that was done here in our laboratory by Dr. Jane Gardner, who I mentioned at the start, who's at New College of Florida, compared the sort of how 3 different species, the blacktip, nurse shark, and bonnethead, get to their prey, and they all use different senses as their primary driver to find the prey. But all the species, as far as we know, have the capability for all 6. They're just developed to different levels.
Okay, so we've kind of bumped up to our 30-minute window here, but I do want to end on this question. It may not necessarily have to do with some of the senses that we talked about, but it does have a lot to do with the work that OCEARCH is doing as a whole. Our tracker has been lighting up with white sharks all up and down the East Coast. Is this a new phenomenon, Dr. Huter? You will probably I know the answer to this, but why are we seeing so many white shark pings along the East Coast now? What's causing that?
Well, of course, we're seeing the pings because we've gotten about 60 of them tagged with our satellite tags. So now we're just revealing what was always there, and it's very exciting as this information and these patterns come forward. I think what maybe the reader or the viewer is asking, maybe alluding to, is the fact that we're seeing them cluster in certain places, like off the Carolinas and Georgia in the wintertime. We think that's for feeding purposes. We certainly see them cluster up in the Cape Cod area, and now we know in Nova Scotia in the summertime, also for feeding. We know where they're giving birth, which is up off of the Long Island area. One of the interesting questions, though, is all this movement to the north up into Canada that we're the first to really reveal. That these animals are pretty common up in places like Nova Scotia. We don't know yet whether this is due to a shift in their range that might be related to something like climate change and temperatures, warmer temperatures going farther north. And true to this particular session, it's their senses that drive them to do this, to go farther north. They pick up on temperature, they pick up on smell, they're following the bait, and it may take them to these newer places outside of their traditional range.
Excellent. Sorry, Lindsay, I did not mean to put the graphics in front of your smiling face. I tried to move things around, but sorry about that.
No worries.
Thank you, guys. Thank you, everybody, for all of your wonderful questions. We hope that that everybody learned a little bit of something here. I just wanted to make you aware that there are other resources out there where you can learn lots about sharks. A lot of people don't know this, but SeaWorld's one of the pillars of our partnership with SeaWorld is, in fact, education as well. SeaWorld has put together a fantastic resource where you can go to learn more about sharks and rays. You can see the website right there. But it is, like I said, it's a very valuable partnership that goes well beyond what a lot of people see, just with the veterinarians, their rescue work, and all that really comes together to build a very healthy partnership. So with that, I want to take an opportunity to also thank Lindsay and Dr. Huter and everybody who tuned in. Like we started out at the beginning of this, clearly we are in some unique circumstances, and we're all here just trying to make the best of it. And so just by coming and being a part of this, makes this whole experience better for us too. So thank you, everybody. Lindsay, Dr. Huter, do you guys have anything, last words you want to say before we sign off?
Thank you so much, Dr. Huter, for sharing your incredible knowledge about these amazing animals. And thank you, everybody, for joining us. If you have any questions, we will try and answer them in the comments section. And we hope to see you all again real soon.
Yes, on that note, there were a couple of questions we did not get to. I will be spending some time going into the comments and responding to all of those. So just because we didn't get to your question, we won't ignore you, I promise. With that, Dr. Huter.
No, thank you, everybody. Thanks for tuning in on these during this different kind of time. I think when you think about it, OSearch was built for a situation just like this, and our ability to reach out to you through the internet and continue our work together. And I want to thank Lindsay. It's the teachers who really make all the difference in this world, that walk us through these things. So it was a teacher that got me on my path as a marine biologist. And I just want to give a shout out to her and all the great teachers out there.
Oh, thank you so much.
All right, everybody. We will be trying to set up some more of these sessions. We're going to try and set up some more grade-specific sessions to go through some of our free STEM curriculum classes next week that are going to be more grade-specific, whether it's K through 5 or middle school or high school levels. So keep an eye on all of our social media channels for those upcoming events. And with that, we will see you all next time. Thanks again.
Bye-bye.